In the last example, we took a look at writing polynomials with complex numbers, and this is 2.5 day 1 that we're in right now. We're going to continue that work with the idea of multiplicity in mind, and we're not going to actually write out or FOIL out the entire thing like we did in the last couple examples. We're going to save a little bit of time and just set it up for this one so that you can know how to set it up, and then refer to the previous examples as far as getting tips on the foiling and making sure you get it in standard form. So we are again going to write a polynomial with a minimum degree, standard form, real coefficients. So we are eventually going to get rid of the imaginaries, but notice here that we've got the multiplicities named. So first of all, we have zeros with one of them being -1. So that means if we're building this equation, that is x plus 1. But since the multiplicity is 2, then we're going to square it. For the other one here, -2 minus I, it has a multiplicity of 1, so that just means it's a normal one. But remember that it has to also have a partner with it. So -2 minus I goes with -2 plus I. Imaginaries always come in pairs. And so when we set these other two up, we're going to do x minus this first one, -2 minus I. And then we're also going to do x minus this one. We've got it set up. Like I said, the foiling part, the big long process that we used in the last example, refer to the last example for this one. We're going to leave that as is for now, because then otherwise it would be a bigger problem than the last one that we had. One other thing I'll mention about multiplicities is just there are going to be a couple problems in your assignment where you have to identify or narrow down the choices based on multiplicities. And so remember that zeros with odd multiplicities are going to cross the x-axis. So if we're looking at the two that we have here, this would be the one that has an odd multiplicity, whatever that happens to be. We don't know for sure what it is in this one without knowing the actual equation. And if it's an even multiplicity, then it touches the x-axis or it bounces. And in this case, we have an even multiplicity right there because it does bounce. So that's kind of just dipping back into the idea of multiplicity a little bit. Again, refer to the previous examples for all the foiling details.